will be discussing today the third equation of motion. We have done through the graphical method. Today we'll be going through the calculus method. We have already done the two equation of motion. One is a v is equals to u plus at, and the second equation of motion, that is s equals to ut plus half at square. That we have already done. Now what we are going to do, we are going to derive the third equation of motion, that is v square is equals to u square plus 2as. Here we'll be using the same formula that we have done in the last class, that we have considered as a dx as a displacement and dt as a time. We'll be considering that only here. So suppose let us consider that dx is a displacement in time dt, so we can write a formula as v is equals to dx by dt. We can write in this way. Okay, so v is equals to dx by dt. Here what I will be doing, multiplying and dividing by dv, on the right hand side. Okay, on the right hand side. So v will be equals to dx by dt dv by dv. Now what I will be doing, I will be changing the position of the dv. So this I can write as dx by dv, then I can write as dv by dt. I have just changed the position of dv and dt. Clear? So dx by dv into dv by dt. We know that the rate of change of velocity is called as a acceleration. So here this will be your acceleration. So dx by dv, this will be acceleration. So now if I cross multiply, I can write as v dv will be equals to a into dx. I'll be marking this as equation number 1. After this, if I integrate both sides, integrating, what we get, you see, after integrating both sides, we'll be getting as integration of v dv, integration of a dx. Then if I implies it, since your variable here it is v, so I can integrate over this v. Here it is, variable is x, I cannot integrate over this a, so a will be coming out of integration. So this, if I integrate it, will be leaving this step here, will be equals to a integration of dx. Okay, so integration of v dv, a integration dx. Now if I break this, so what will I get? If I break this, I'll be getting as integration of v dv, it will be v square by 2 equals to a integration dx. Integration of dx is x, so it will be ax plus, it will be coming as a constant, v square by 2 is equals to ax plus k. I'll be marking this as equation number 2. Now for the initial time, okay, for the initial time, if t is equals to 0, what will be v then? V will be equals to u, that is initial velocity. Now if I put the formula here, what will I get? So I'll be getting as v will be u square by 2. This will be considered as a 0 because at the position of t is equals to 0, your displacement will be equals to 0. So your k will be equals to u square by 2. So equation 2 implies v square by 2 equals to ax plus u square by 2. Okay, now if I simplify more, I'll be getting as v square minus u square, and this 2 I can put on that side. I have skipped one step. Okay, I have put this u this side, so it will be minus u square by 2, then I can cross multiply 2, so it will be 2ax. So the formula is v square is equals to u square plus 2ax. So this is the third equation of motion. So we have done the first equation, second equation, also the third equation of motion. So based on this, we'll be discussing some more questions related to this. That means we'll be discussing some numerical on the next class. So we'll be discussing up till here for today. So thank you.